Welcome to Natural Habitat Adventures Daily Dose of Nature. I'm your host, Kendall Bauer, and today's presentation is Peatlands, Earth's Carbon Time Capsules, presented by NetHub Expedition Leader Charlie Reinertsen. And today he is joined by a very special guest who I will let him introduce. So Charlie, off to you.
Thank you, Kendall, and welcome everyone. I'm really excited to be joined today by Dr. Curt Stager, who's a paleoclimatologist. We're going to unpack that title in case you're not familiar with that one. And we're going to dive into peatlands today and talk about this amazing ecosystem. We're calling in from Saranac Lake, New York, which is in the heart of Adera Park. And we have this incredibly rare ecosystem in this area. And that'll be kind of our jumping off point to talk about what we can learn about climate from studying peatlands. So we'll do a couple introductions. I'll introduce you to Curt, and we'll do a quick crash course on Peat 101. What is it? What are peatlands? Why are they important? And the rest of the hour will be filled with an interview learning from Dr. J. Curt Stager's work in the field of paleoclimatology. And we'll wrap up with any questions that you might have, so feel free to drop those in the chat as we go. So just a little bit of background about me. I've worked in science communications for the past 10 years, and I love connecting people to the natural world. And so I occasionally get to guide trips with Natural Habitat Adventures in Grand Teton and Yellowstone, as well as in Michoacan, Mexico for the monarch butterfly migration. And one of the projects that I've been working on through my company, Two Line Studio, is the Northern Peatlands Project. And it's really trying to raise awareness of what are peatlands, why should we care about them, and hopefully inspire further restoration and conservation of these areas. And I'm really excited today to be joined by Dr. Curt Stager. And Curt is a paleoclimatologist, an author, and a professor at Paul Smith College. In 2013, he was named Science Professor of the Year for New York State by the Carnegie Foundation. He's also the author of 4 books, including Still Waters, The Secret World of Lakes. He lives and works right here in Adera Park. And we're in the heart, if you're not familiar with it, we're in the heart of a 6 million acre wilderness area in New York State. So let's dive in just to some very quick Peat 101 before we have these questions with Curt. And in this area, what is peat? Peat is this organic material that is incredibly dense with carbon. And essentially what's happened is we've had water bodies that over hundreds and thousands of years have accumulated vegetation in the bottom of the waterways. And as that vegetation accumulates, it creates really acidic conditions, which makes it so that microbes, which typically break down organic material, are very low activity level. And that allows for this vegetation to gather and build up, with the oldest layers being at the bottom of the body of water. On this graphic, you're seeing a peat core, so trying to look at the very top layer is living sphagnum moss and then some recently dead material, and then as you go down, you're getting into those layers of peat. And just wrapping our heads around what a peatland is, it's a type of wetland. We're hearing more and more about how important wetlands are in terms of their climatability as well as protecting biodiversity, and peatlands are within that umbrella. And you might have heard of fens, bogs, or even mires, all of which are peatlands. Now, why is peat important? Peat is incredibly important because it's a really rare ecosystem. Only 3% of Earth is covered in peatlands. But it's really important from a climate perspective because it stores an incredible amount of carbon. Almost 50% of Earth's soil carbon is stored in our peatlands. And that's more than twice as much as our global forests store in their soil carbon. In addition to the carbon benefit that we also have biodiversity hotspots in all of our peatlands throughout the world. There are plants and animals that live in these places that do not live anywhere else. So for those reasons, it's incredibly important to protect and restore and conserve these habitats. But today, we're really using this as a jumping off point to ask the question, what can we learn by studying peat? And that's why I've asked Curt to be able to join me today and speak to his work in paleoclimatology. And the question that you've been asking since the beginning of this presentation is our first question. And it is, what does it mean to be a paleoclimatologist? And before we dive into that, I'm going to stop sharing my screen so you can just roll over just to the video chat and we'll go through these questions. Just give me a quick moment to be able to switch over here. Great. So, Curt, thank you for joining me.
Yeah, it's great to be here. Nice to meet you all too.
And let's dive into that word. We're trying to figure out, what does it mean to be a paleoclimatologist?
Yeah, I wish we had a shorter version of the term that we could use. It's a person who studies climate, but not just the climate today, but climate of the past as well. Paleo refers to the old days and stuff too. So it's basically climate history, but linking it to today so we can take lessons of the past to teach us about what's going on now and where are we headed in the future.
That's great. And so what, researchers are really driven by their questions. What are the types of questions that paleoclimatologists are interested in researching? And why is this research so important?
Mm-hmm. One of the reasons paleoclimatology is important nowadays is because when people talk about climate change now, you still sometimes have people ask questions about how do we know that what's happening now is because of us and not just some natural cycle that happens. And of course, there are natural cycles, right? Ice ages come and go, and things like that. Well, this is where the paleo science comes in, because it helps us say, what are the natural cycles? How do they affect the world? How long do they play out over? What makes them happen? And then how do we know that what's happening now is not due to that? So that's one of the key contributions, actually, paleoclimate science has done to the global warming topic. Basically, to make the long story short, is we're able to say it's not a natural cycle, what's been happening in the last century or so. So that's a big one.
Yeah, that's a very big question.
There's one other big one, too, is that has to do with the future and our conditions today. Because, yes, indeed, there were climate changes in the past. So it's gotten warmer, it's gotten cooler and things like that. So by looking to the past, we can say, what did the last great warming of the earth do to the world and the species and maybe the people living in it? So we can then get an idea what we're heading into as we warm the world ourselves.
Wow.
So
those are big questions.
Yeah, it's great to be doing research that actually has some use.
Yeah, absolutely. And I feel like so often we read about climate change in the news, we see it all over the headlines, and it's really comforting to sit down with someone who's working on this issue and be able to hear firsthand about what it is on the ground that you're doing to be able to answer these questions. So, we're calling in here from Saranac Lake, and that's in the northern portion of New York State. But what makes this area, Adirondack Park, an ideal place for your research?
There are a couple of things that make this just the perfect spot to not only work with peatlands, but also other wet habitats like lakes, which is my main specialty. And there are a couple of big reasons why it's really good. One of them is this sector of the continent's pretty wet compared to a lot of the rest of the country, like let's say the Southwest, right? So it's not a desert, whatever. So we have plenty of water, and that's what you need to have wetlands. The water tables come up, and you can see them at the surface, and the plants are affected. So there's that. The other thing is this Adirondack Park is centered on a giant rugged landscape, a big upland dome. And because it's rough, it's got valleys and hollows and such, it collects the water. So it keeps the water body there long enough for the vegetation to come in and make a peatland or to make a lake or something like that.
Yeah.
And the third and last thing has to do with us. And that's because we're in a 6 million acre state park with strong environmental laws protecting it. And so the wetlands cannot be drained to make a parking lot,
right,
let's say like that. And so we've got at least 3,000 lakes and ponds here, and easily, well, several times more than that of peatlands of various sizes, from the size of your house to what you love to study, Spring Pond Bog, right? Is that the
Yeah,
one?
that is the preserve. Yeah.
Yeah.
Yeah. But that's really interesting. And for those who aren't aware, I'm trying to remember dates here. You'll help me out. But Adirondack Park was established in the late 1800s.
Yes, that's close enough.
And at the time, there were a number of different people coming together to conserve this area. One of the primary reasons was that there had been a lot of log drives, and so this area was deforested prior to that time, mostly to get wood products for building. And so a number of people came together because suddenly the water resource was starting to get really degraded. And so the idea was we can protect this area, protect our water that ultimately, is fed to all of New York State, all the way down to New York City. And that was kind of the concept behind Adirondack Park. Now, you're going to laugh because that was a really abbreviated version, and it's a very complicated story with a lot of different reasons why this area ultimately was conserved. But it's led to essentially a bit of a playground for researchers like you because it is closer to what we anticipate these ecosystems would have been without human influence.
That's right.
And so that's a really exciting place to be. But you touched on this already a little bit. But what role do peatlands play in paleoclimatology?
One of the great things about peatlands, in addition to being carbon sinks, where they're taking carbon out of the air, making plant bodies out of it, and then keeping the carbon dioxide that would have been in the air in the ground instead, and affecting climate that way. Another thing is because the remains of the plants and other organisms that were in there are still preserved in those layers, they're an archive of the ecological history of the landscape.
That's amazing.
It's like the memory banks of the mountains that are in there. And so if you want to know what the climate was like, you might want to know what the vegetation was like. How long were the forests here? How long was the wetland here? Those kinds of questions. How often did the forest burn? Did there used to be lots of forest fires and not so many now? Those kinds of questions. Those are all preserved in the layers that you were just talking about, where you have the live moss and then the ancestors of that moss below that and so on back through time, thousands of years. You can probe back through there and take these little time capsules from the past and tell the stories of what this place was like through time leading up to today.
So you're not only a researcher, you're also a detective. Do you go out with a magnifying glass?
Yeah, well, sure. Call it a microscope, but yeah, absolutely.
Yeah, and we talked about this a little bit earlier, but I think it's helpful because it's a fairly hard concept to wrap our heads around. Just that idea of how peatlands are formed, and getting into as we look at those layers of the peatland, what is it we can learn from them? Are there more specific things to add there?
Yeah. Well, you could kind of you showed a really nice slide there, what a peat core looks like, but I brought a sample from a local wetland that you can actually show people here. One of the things that defines, let's say, a peatland that you'd call a bog is a lot of mosses. And so here's one of the standard kinds of moss. You call it peat moss or sphagnum moss, things like that, and spongy and everything. And you love this stuff, and there are many species you could talk about, right?
Yeah,
all
absolutely.
different colors. Well, when these die, because of what Charlie was talking about, the acidic water kills off most of the decay microbes, and so the bodies of these will stay there, and their descendants will grow on top of them and sort of bury them under. So when I went out on the bog today and I reached in and I pulled this up, beneath these were their ancestors farther back. These are like their great grandparents or older ancestors back through time. And so, the green is gone, but the fibrous material from the bodies of their ancestors is still here. And the deeper you go, the more weight there is, the more it squeezes the water out. So this fibrous looking stuff, you could say, would get squeezed. Look at all the water coming out. And there's like a glob of denser and denser peat that you could then take a cylindrical core through and watch the time sequence, actually upwards, right? The oldest would be down below up towards the present day.
That's amazing. Yeah, and that just gives you such a visual for, what we're actually talking about here. And I've heard reference that peat moss, which is sphagnum, can hold up to 20 times its weight in water. So that was a perfect visual to be able to squeeze it and just show all the water that it's holding. And that helps to maintain the water levels at a consistent place to have vegetation that can both survive in it and absorb so much of it so it doesn't just evaporate. So these are really special spots.
Oh, God.
You were referencing, some tools that you use to be able to get your sample of peat that you'll then analyze in the lab to be able to learn more about. But what are some of those tools?
One way to sample the past like that is, depending on how thick the layers are, you'd use different techniques. So an easy one would be if the peatland was only a foot or two deep. Well, then you'd sort of reach in with your hand if you wanted to, or cut a little trench. But the bog that I went to today has 20 feet, 20 feet of peat under it. So you need a special piece of equipment. So one of these standard tools is called a Russian peat sampler, and I do have one here. And it looks like a scary weapon. It looks like a rocket launcher, actually. Just imagine what it's like and trying to get through airport security with this.
Oh my gosh.
I've had to do that, actually.
Imagine.
And unfortunately, the last time I tried it, the person who made this for me also sent it in a gun case.
Oh, jeez.
So, but the deal is, we're holding it horizontally right now. But if you go like this and you have it pointing down, it's very sturdy and heavy, and this will penetrate down through that fibrous stuff.
Okay.
And you push down, and there are extension rods. Like imagine we're pushing it down now into the peat, and there's maybe you want to hold that, and you can screw another rod onto it to make it longer, and it just goes on and on and on until you hit the bottom, basically. Well, once it's in there, I'm trying not to ruin your table here. Just hold the base there like that. Then you rotate it from above, and this just closes over that flange, and inside now will be a cylinder of peat. And you pull it up, lay it flat, and open it up, and there's your beautiful, I had it off the screen there, yeah. So you just open that up, and there's a half cylinder, like a half sausage, with the layers all intact. And when you pull it up from the bottom, you can see if you've got maybe sand on the bottom from before the wetland was there. Maybe it was a lake before.
Wow.
Or you can see dark bands in it, and that would be charcoal from forest fires.
Wow.
So the kinds of questions you can ask would be, let's say, of interest to a forester. They want to say, we're in this beautiful park. We don't want it to burn up, but forest fires are natural too. How often do the Adirondacks naturally burn?
Yeah.
Well, you could tell from a core like this.
Wow.
And say, well, it's once a century or something like that.
Okay, so this machine is it's a tool. It's about 2.5 feet in length, maybe a little less.
Yep.
So if you're gonna sample, say, 20 feet of core, you're taking a lot of different samples at different depths.
Yep.
And then there must be a pretty good spreadsheet to be able to tie all those together.
Oh, you have to be really careful because you're out there on this springy, spongy mat, right? Like walking on a wet trampoline, right? And you're pushing this thing down in and screwing on the rods. You pull up one section at a time and then push it down farther. So you got to keep track of how many rods did we just screw together to push that down last time? And was it 6 or 7 of them? I can't remember. Oh no, we just lost the layer sequence. Now we have to do it all again.
Oh my gosh.
So it takes real teamwork and real concentration and very good note taking of everything you're doing so that you can look back on it and reconstruct what you did.
Wow, that's amazing. Any surprises that you've pulled out of the peat?
Oh my gosh, they're all kinds of really fun things.
We're going off script here.
No, it's fun. It's fun. I tell my students when we go out there that you can find, the remains of plants and mosses and pollen to tell you what the forest was like and what the charcoal was like. But sometimes you find animals in there. The biggest animal I've ever found was beetle wings. And that's actually valuable because the species of beetle in the past can tell you about the climate, actually. Wow. But other people that I tell my students about have actually found people in peat bogs in other parts of the world, like in Europe. 4,000 years ago in Northern Europe, it was common to take a criminal. The community would kill them and throw their body in the peat bog.
I've read about the bog bodies.
The bog
Yeah.
man of
Yeah.
such and such a place, and they're very well preserved. They're mummified, basically, just like plants are. And other folks in North America have found the remains of mammoths and mastodons in there, like not fossil, but the actual mummified bodies with the fur and everything.
Right.
Which then lets you open them up and see what's in their stomach and see what they were eating as well. So from that, we know that in New York State, let's say mastodons lived in the forests and they ate spruce trees because you could find it in their stomach when you dig them up from peat bogs.
I never would have guessed that.
It's amazing. Spruce, yeah, imagine that. Yeah. If we were hiking in the Adirondacks 12,000 years ago, you'd have to have mammoth bells on your pack, just like you have grizzly bear bells in Yellowstone, right?
Yeah.
Is that what you do?
Yeah. That's amazing.
Or mastodon mace.
Yeah, right.
Walking in the woods.
Wow. So, we've been talking a lot about peatlands and their role in paleoclimatology. You mentioned earlier that a big focus of your area is looking at lakes. But what are other ways beyond just studying peatlands that you can study, paleoclimatology?
Yeah. Pretty much anything that makes layers is a potential archive of the past. So let's say you go to the polar regions. There's no open water lakes. There's no open water peatlands or anything, but there's snow. And so if you go to Greenland or Antarctica, the snow builds up into the ice caps there. And you can core down through those even as much as a mile of ice with the annual layers. Look at the chemistry of that. You can reconstruct climate. You can find volcanic ash from volcanic eruptions, which then lets you date them to the exact year or even season when they happen.
Amazing.
Or any place that mud accumulates. So under an ocean, under a lake, those kinds of places. Sometimes the color of the sediment changes from summer to winter, so it's light and dark banded, and you can count them like pages.
Interesting.
Back through time. So basically anything that accumulates can be used.
Yeah.
And in the case of peatlands, you've got the layers of peat.
Yeah, perfect. And so, here in Adirondack Park, there are a lot of dams, more than 500 dams. How does that impact your ability to look at the layers, or is it just that you see something different happen at a certain point in time?
Yeah. Well, as you know, you study the interactions of people and the climate and the environment here with your peatlands. And one of the things, like you said, is although we're in this 6 million acre beautiful park, it's not unimpacted by people. And so some of these wetlands are young because they were made when the dams were built. Mm-hmm. And they lifted the level of the lake, like Tupper Lake is an example.
Right.
It's got a beautiful big lake, and as you're leaving the town in one direction, you're kind of going on this causeway through a marshy area, and what a beautiful wetland. And if you look really close, there are dead tree stumps in there.
Yeah.
And that's because 100 years ago, when the dam was built, it reached up and flooded. So if you were a paleo person thinking, oh, look at that wonderful wetland in Tupper Lake, let's see how old it is. And you take your sampler, and it wouldn't go in very far because there's no history there.
Wow.
For us, 100 years is no history. Yeah. Right? So you really have to know your area. So other places, people tend to drain the wetlands, and that's, you can actually walk out then and collect the peat that way. Here, flood the areas more, and so we're actually making wetlands at the present time more than destroying them here.
Interesting. Yeah. I've heard even that some of the peatlands were flooded out by putting in the dams, which I've not area pre-Adirondack Park to be able to know what.
Well, when you have these dams here, of course, the water level went up. And before the dam was there, of course, there were wetlands around the edges, right? So anything that was there as a marsh or a wetland originally will now be underwater.
Right.
So that's another thing. Maybe the most dramatic example I can think of for that is people who take sediment cores from the ocean. And one of my colleagues from Canada goes out into the Bering Sea off Alaska, between Alaska and Siberia. They have echo soundings from their boat bouncing down to the bottom of the ocean there, and they're looking for old lakes and old peatlands that are under the ocean now,
Wow.
because that place used to be what we call the Bering Land Bridge between Asia and North America, where people came over thousands of years ago before the sea level came up and covered it. So you can actually have freshwater lake and peat deposits under the ocean.
That's
You
amazing.
can sample that way to see what the environment was like when people came across from Asia.
Oh, so many questions you can ask. It's amazing. So you've been sharing some of this, and you just did one right now, but are there other things that either the field or you have found by asking these questions that would surprise our listeners today?
Well, lots of them, lots of ones that surprise us, which is one of the amazing things. It's when you take these cores and you open them up, it's like, well, you're not going to find gold like you would in an Egyptian tomb, but it can certainly be feeling like that, because when you open the Egyptian tomb, you not only find the gold, but you find the hieroglyphs and the stories of the people in the time, and that's what you find in these cores. So just one example. Nowadays, with invasive species happening, sometimes we're losing some of our species of tree. Let's say like elm trees died off from Dutch elm disease and things like that. And you might wonder, can they recover? And if so, how long does that take? So we actually have an example of a tree decline here in North America 5,000 years ago that you can see in the peat cores from the pollen.
Interesting.
And before that, for thousands of years, there were lots and lots of hemlock trees around here mixed in with the other trees. And then about 5,000 years ago or so, poof, the hemlock pollen in the core layers just vanishes pretty much over a matter of like a century or so.
And do we know why?
No one knows why. It certainly wasn't, people bringing over imported trees from Europe or anything, because this was before that. So the two best guesses are a pathogen, some kind of microbe figured out how to kill hemlock trees, and another one would be climate, and there really isn't a big climatic change around there.
Wow.
So it's a mystery. It's a great mystery. But the other thing is, like, it shows you that if you do lose a species, they can come back.
Yeah,
because the hemlock is back now. But in this case, it took centuries. So
amazing.
It forces you to have a long-term view of environmental changes we're doing today. And you can find both hope and despair in those stories, depending on what your personal view of the world is. Like in the case of the hemlocks, you can say, well, it took hundreds of years for them to come back.
Right.
And if we lose a species now, we may face that again, and we'd never see them again in our lifetimes, let's say. The flip side is, if you do wipe them out, maybe you don't wipe them all out, and the species will eventually recover if you don't keep hammering it.
I'll find hope there.
I prefer that too.
Yeah. Interesting. So in this work, when we're looking at layers of peat, one thing that strikes me is you hear about radiocarbon dating in other fields. Is there any aspect of that with this work? Like, is there some way when you've gone down to the bottom layer and you're looking at what's happening there, how are you actually putting that against a timeline?
Yeah, there are lots of different ways. In some cases, you could say we have good dated records elsewhere. Let's say, well, that hemlock decline, right? It's been documented in so many locations with carbon-14 dating that if you find it in your place, you say, well, we know that was 5,000 years ago. You look at the pollen grains and suddenly they're gone. Oh, that must be the hemlock decline. So you can do it just by looking, let's say, through a microscope at a sample. But the great thing about peatlands is the organic matter, the dead peat that you're looking at is full of carbon, like you said, right? And it was maybe going to go in the air. Well, there's radioactive carbon in here, and that's the material you can date with. And so
interesting.
Two of the great things about it is there's like a ton of carbon. So you just need like just a little tiny, even a smaller pinch than that to get a carbon-14 date.
Amazing.
Mail it off to a lab with $600 and you wait a month and it comes to you like that. But the other good thing is, in a way, it's better than my specialty site, which is lakes, because sometimes lakes get churned up. Sometimes a river comes in and drops old material in there, and now the mud looks older than it really was. Or, that's not going to happen with this. Unless the mastodon were stomping in it and mixing up the layers, these are pretty much in position. And so if you do take your carbon-14 dates layer by layer upwards, you can make a really good sequence.
Interesting.
And get a good history there.
Yeah, that's great. So another question we had is just, how does a study of Earth's climate in the past help us understand human impact on climate today? You've touched on this a little bit, but we're really in this time where we're trying to wrap our heads around climate change and what does it mean and what does it mean for the ecosystems that we live in. So what, as a paleoclimatologist, what's your perspective that you bring to that? How can that help us wrap our heads around where we are today?
Yeah. Well, when global warming and climate change in general really caught the public's attention, now what would you say, like 10, 20 years ago, right?
Yeah.
People in our field had been doing paleoclimate for a long time, reconstructing ice ages and things like that. And we were just sort of off in our little corner doing our little academic thing. And we were just fascinated for its own sake. But then as people started asking about the modern warming, this question came up, was how do we know that we're not just in a natural climate event? And so the paleo community rallied, went back, looked more carefully at their records and said, we can do better than that. We have to sample more precisely and make really sure what we're looking at and take more samples in more places and date them more. So it made us all go back to the drawing board. And we've been able to come back and say, yep, it's not a natural cycle. We can name them. If somebody asks you, or if somebody tells you the warming now is just a natural cycle, you can ask them, which one? Which one? Name it. There is none that will explain what's going on now. So just one example. To me, if people were more familiar with the techniques, would have saved us a lot of argument years ago. Some colleagues in Canada have been going up to the Arctic lakes, the high Arctic of Canada, for years, collecting their samples, and they would go in the summer and they'd walk out on the frozen surface of these little shallow ponds and drill a hole and then put a sampler down through there and pull up the lake mud and do this kind of work. And two things happened. One was that over the years, the ice got thinner and thinner when they go up there in the summer, until now some of them don't freeze at all, or they get a little rim of water around them. And because the ice is off the lakes, the little algae can now grow in the plankton of the water of the lake. And when those algae die, little microscopic creatures and plants will fall to the bottom, and they'll now be in the layers of sediment. So what they're finding now is in lake after lake after lake in the Arctic, the uppermost layers have the preserved algae that will only live in a lake that has no ice on it or that has meltwater around it.
Yeah.
So by looking back thousands of years into the layers under those lakes, in those sediments, they can see that has never happened before.
Wow.
In the entire history of these lakes, thousands of years, there is no other section that has open water algae in it.
Wow.
So you could show, if this were a climate cycle, you'd find, okay, it's happening now. Oh, and it happened 1,000 years ago and 2,000 years ago. And like a cycle repeats, right? There is no repeat to what's going on today. So, and this is all over the Arctic. So to me, it's like game over for the argument.
Yeah.
That's all you need to know.
Right.
And it's from paleo climate studies.
And when about were you aware of that, being in the field itself? Like, when was that conversation happening?
I freely admit I was among the climate skeptics early on. A dear friend of mine who's a noted environmental activist, a climate activist, Bill McKibben, was up here years and years and years ago, and we talked, and I said, well, I think your ideas are great, but the scientific community is not yet sure. And so he used to tell people about me. Oh, Curt Stager, he doesn't believe. Well, that's actually, being a skeptic is a sign of a good scientist, actually. If you're a true skeptic, you wait until you have enough evidence to make a clear decision. And we just didn't have it at the time.
And for you, that moment was discovering that open water algae didn't exist in cycles.
Example after example like that, from the paleo world, convinced people in the climate community, myself included. And so we changed our minds and now say, yes, it's rock solid. And I make that distinction between a skeptic, which is what you should be as a scientist, and show me the evidence.
Yep.
That's different from being, let's say, a denier or somebody who says, I don't care what evidence you give me, I made up my mind.
Yeah.
So there's nothing wrong with being wrong.
Right.
In the sciences. That's sort of the magic of it.
It is.
The thrill of changing your worldview in the light of evidence.
Thanks for sharing it. That's very interesting. I think that's a story that I think more people could benefit from hearing. And I think it's, especially today, saying that story today, some people might not say that. I think it's encouraging to hear it and to know that that's, where you were thinking. So just a couple more questions here before we open up to questions from our audience. What are some of the ways that climate change is going to impact this particular place here in Adirondack Park?
Yeah. Well, there's no question that because of the fossil fuel carbon dioxide, the heat trapping gases that we've already emitted, the whole planet as an average is going to get warmer. And it's going to be getting warmer for a long time. Different parts of the world will do it more or less. But the locations that are closer to the polar regions will get more of that. And there are various reasons for it. And because we're in the northern part of the United States, whatever, we're closer, and we're actually warming faster than the global average here.
Okay.
So we can expect that to happen. And so even if we switch as quickly as possible from fossil fuels to the renewables, which we have to do anyway, because we're going to run out of fossil fuels, right? Eventually, let's do the switch now. Even if we switch relatively quickly, we're going to see centuries of warmer climates than what we think of as normal today. And here in the Adirondacks, we mainly see that as the retreat of winter.
Yeah.
And you can see that in people's diaries, ice out contests on the lakes, or actual scientific observations showing that the lakes here are freezing later on average as winter starts later, and thawing earlier in the spring as spring comes earlier. So winter is basically shrinking and summer is getting longer. I've even noticed it in the 30, 40 years I've been here. The summer now sort of leaks over into September in dramatic ways. And so longer, hotter summers and shorter, milder winters is what we're looking at.
Really interesting.
Yeah.
Wow. And just thinking about peatlands, that they're a little bit of an interesting ecosystem because they both are going to be a part of the solution. If we restore more, they can sequester more carbon.
Yeah.
But they're also on the receiving end too. So what changes do you anticipate to our peatlands here?
Yeah. Well, the peatlands here not only depend on temperature, but also on rainfall and snow melted things to provide the water that makes them a wet land. And unfortunately, we can't really be sure from the climate models which way we're headed in that regard here in the Northeast. Some models say it's going to get wetter. Some say it's going to get drier. Some models say, well, it's going to get kind of wetter, but also hotter. And so because it's hotter, it evaporates more and it makes up for that. So we're not quite sure what the water levels are going to be. If we end up getting drier, our peatlands are in trouble.
Yeah.
But we do have one maybe tiebreaker if you're a paleo chauvinist like myself. We do have paleo records from here. My research and others shows that we actually had a relatively warm time 1,000 years ago.
Interesting.
It was not caused by people. It was just a mild warm time, followed by a mild cooler time, which is really useful for us.
Yeah.
Because we can say, well, what happened last time it got warmer or cooler here? What did the rainfall do?
Right.
And looking in the lake and peat peatland records, we see that when it got a little warmer here, it got drier. The water levels dropped.
Interesting.
And after that, as it got cooler, it also got a little wetter. And that's when a lot of our peatlands started to grow.
Wow.
And also on a larger scale, there was a warm time before that when you can see that like this bog where I collected these samples from formed about 7,000 years ago because there was a warm, dry time that gave way to cooler and wetter, and that allowed the bog to form.
Brought it back. Interesting.
So as a paleo chauvinist, I would say, okay, the paleo record favors the models that say it's going to get drier here.
Interesting. Very interesting. Well, time will tell.
We'll see, or our descendants will see.
Yeah, exactly. And I think that kind of brings us to our last question here, unless you have more to share that you were interested in talking about. But as someone studying climate change and who's been in this field for so long, we're faced with tons of news that's pretty dire and that is pretty hard to take in and process. Yeah. Where are you finding sources of hope?
Yeah. I'm going to ask the same thing of you in just a second.
Okay.
Yes, it's a hard time. If you pay attention to science and facts and things which actually do exist, it can be pretty dire, like you said. But as a climate or environmental historian, of course, I also have a long-term perspective, and that actually helps. I think, if we have any elders in the audience too, right? You know how different the world looks when you experience it as a very young person, when you don't have a lot of experiences compared to an older person. And you realize that when your boyfriend or girlfriend broke up with you, you actually got over it eventually, that kind of a thing. So just knowing that things can get better even when they're bad. You see that in the ancient history of the world.
Yeah.
And so I think the main takeaway message that I get from the paleo record that gives me hope fits in with a saying that a biologist in the 1800s used to say, Thomas Henry Huxley. And he said, we need to learn what is true in order to do what is right. And use the science to give you the physical facts and the physical reality to then make your judgments about how to make the world a better place. And what seems clear to me is from the facts that we have become a force of nature on par with ice ages and volcanoes and things like that. We see it in the paleo record. The changes we're making now are just as big as everything else. It means we're a force of nature. We've done these things inadvertently without knowing how powerful we are. Well, if we wake up and realize that we are a force of nature, we are also a force for good.
Yeah.
And if we take that power, we can actually make the world better instead of more damaged. So that's where I find my hope.
Yeah.
But what about you?
No, that was really, I love that. I love the sentiment of that. I think I share some of the, when you study ecology, you start to learn just like how resilient on a whole life is. Not necessarily individual species. Individual species come and go. But even there are specific examples of some species that have just such an ability to bounce back from being in a bad way. Like the monarch butterfly, they have such a huge ability to lay a ton of eggs at once. And if they have really good conditions, their population can bounce back. And I think it's little examples like that and just kind of on a whole that our perspective on ecology and on life is so limited. And I think we have a responsibility because we have proven time and again that we're responsible for this latest warming. So I think as a species, we have a responsibility to take action. And that's a huge part of why I'm doing the Northern Peatlands Project and trying to get people to think about, hey, what's this place that I haven't heard about? Why should I care about it? Oh, it helps keep our planet cool. It helps give home to plants and animals. I think we have such a huge capacity to care for this world around us. I think that's where I get my hope.
That's a great one. Absolutely.
Well, Curt, thank you so much for taking the time to chat with us. And I'd love to open it up. We have just a few minutes here left for any questions that you all have as we've been going through the conversation. So let's hear from you.
Great. Thank you so much, guys. That was such a thought-provoking, engaging conversation. I really enjoyed it, and I learned a lot. We do have a couple questions ready for you, and I want to invite everyone who's watching, if you have a question today and you haven't submitted it yet, don't be afraid to put that into the questions field. I'll be monitoring that, and we will take questions for the next 10 minutes or so. All right, first question, and Charlie, I'll let you handle who answers what, or if you both want to answer at the same time, that's totally great. What does it take to restore peatlands, and can they come back?
That's a great question. Curt's pointing to me, so I'll take a crack at it, and he's going to fill in any gaps. You know, the big way that we remove peatlands from the landscape is by draining them. And we do that for any number of reasons, whether it's we want to develop that land, either for agricultural purposes or for literal developments, or often peatlands and wetlands generally through human history have really been viewed as this nuisance ecosystem that's filled with disease, that there's all this folklore around peatlands that, you know, you hear about the green light that's going to draw you out into the peat. And so there's, you know, we have a lot of built up history of thinking negatively towards these ecosystems that has led us to drain them and to degrade them over time. And now, because of our awareness of their role in keeping a healthy climate and supporting biodiversity, there are a lot of people starting to restore them. In particular, the way they do that is by, if they've dug ditches into the peat to be able to drain it, you're going in and you're trying to build dams and you're trying to hold water in that ecosystem. And so for a recently degraded peatland, for instance, if you're harvesting sphagnum and peat for horticultural purposes, right? So you're gardening with your sphagnum moss. Those operations typically aren't going to strip the whole peatland clean. They're going to just take the surface layers, and then there is a process to re-wet that area. And then perhaps you go to a really healthy peatland and take some samples to be able to help recolonize the degraded peatland. But obviously this is a complicated question because it really depends on what you've done to that area to then be able to prescribe what you're going to do. And peatlands are found all over the whole world in different ecosystems, different climates. And so each of those peatlands kind of require a little bit of a different approach, but it all starts with getting the water balance right, because peatlands are this really delicate system that requires just the right amount of water to be able to prevent most plants from growing there and to provide perfect habitat for the plants that are able to grow there. But Curt, do you have anything to add there?
No, Charlie's right. If we're talking about human effects on peatlands, the main thing is if you take the water away, you'll take away the life's blood of the wetland.
Right.
So the main threat to peatlands now, of course, is, you know, the climatic changes, because they're broad brush even where people are not there, messing with the stream coming into it or something like that.
Right.
And of course, when you showed your map of where most of the peatlands are, they're up in the Arctic, and they're frozen right now.
Right.
And the big fear is if they thaw out and then dry out, you start losing the whole ecosystem up there.
Wow.
So.
Yeah, that's a whole nother topic. We're even with the dark conversation. It's even getting dark here. We've got a thunderstorm rolling
coming,
in.
Yeah.
That was a great question. What other questions do we have?
Yeah, the next question I think could apply to both of you, so I'd love to hear from both of you on this one. What projects are you currently working on?
I have so many projects. It's hard to keep them all straight. It's just I was like a kid in a candy shop here in the Adirondacks. I work with my students, and we investigate the histories of lakes. One of the fun ones was documenting pristine ecosystems. So to a visitor here, you can look at a lot of our lakes and say, oh, it's untouched wilderness. And of course, as we talked about in this last hour, a lot of them are not untouched, but some of them are. They're real gems amid the costume jewelry. And so what we've done is identify lakes that seem very remote, no obvious record of them having been stocked with fish, let's say, or ever had the forest around them cut by a lumber industry or never dammed. And then we take cores and we compare the present day to the past, going back thousands of years. And we've actually identified one in the central Adirondacks called Wolf Lake, which is the same way it was centuries ago.
Wow.
Or it was until just the last year or two, because some invasive species got in.
Oh no.
But anyway, that was a fun project to look for. Rather than the sad stories of the damaged lakes, it was look for the success stories, the untouched, pristine gems.
Yeah. Well, and that was a loaded question, because Curt is actually a very practiced and talented musician. He's heavily involved in all kinds of humanities projects around the area. So he gave you the climate and science related answer, but he's got a whole long list of projects he's involved in. And I think for me, the big one for me is this Northern Peatlands project. You can take a look at the writing and photography that I've been working on. And it's just really geared towards trying to connect people to this ecosystem that maybe they've never heard about. And I've worked with a number of people and in trying to understand this ecosystem more. My background is in environmental science broadly, but when I first went into this ecosystem, I was just amazed at how little I understood it, even with my environmental science background. And so I've used photography and video as kind of an entry point to then start to research more and more and learn from people like Curt about what they're working on and trying to piece together this big story behind it. So that's been the big part of what I've been working on.
I'm going to pile on that. Charlie's aerial photography is astonishing. Like on this slide, if the one I'm looking at may be the one you are with unlocking a bird's eye view. If you've seen these photographs blown up to full size in art galleries, it stops people in their tracks. And so it's a great thing Charlie is a master of, is combining really good science with the human touch, with the arts as a way to communicate the facts that are going into your brain, connecting it with your heart and your gut as a human being. And using these beautiful photographs as doorways to people to then care about wetlands. Instead of just thinking they're interesting, you want to love them too.
Yeah. Wow, that's awesome. Thank you, Curt. I appreciate that.
Yeah, that's a really great segue to the final question that we have time for today, because it is so important to reach people and to help people understand, what's going on in the world in terms of climate change or other projects that you're working on. And so someone's question here is, how can you make people better understand, especially those in government or powerful positions? How can you make them understand the reality of climate change and the situation that we're in right now?
Wow.
What's some work that you're doing to reach these folks?
I think reconstructing thousands of years of environmental history is much easier than deciphering the human psyche, especially when it comes to politics.
Yeah. I've found, being a expedition leader for Natural Habitat Adventures, it gathers people together around this common ground of being interested in exploring a new part of the world. And I think both of us in our careers of, you in research and also being a professor and teacher, and, I think finding whatever it is that you can stand on and say, hey, we're both pretty interested in that weird looking bird. You just have a conversation. You start to get that place where you're relating to one another before even thinking about talking about politics or anything else. I think that is just a requisite for being able to then have conversations where you disagree. And I think that, the natural world to me is just filled with all these mysteries and curiosities. It's the place where if you allow yourself, you can feel like a kid again, just being like, wow, this is really wild, looking at this crab spider that I found on a, black-eyed Susan in the backyard. And I'm just going to spend some time thinking about how crazy that is. I think if we just use that as an on-ramp to be able to have a shared experience, shared interests, I have to think that we'll get to a place where we can hopefully work together to be able to prioritize restoration and conservation. And hopefully it'll happen before it's too late to really do that in an effective way.
Yeah.
And people debate what too late is, but I think that's what I have to hold on to, is that those trips are such a little example of, on the bigger picture, that when you have the opportunity to connect with people about a shared interest, it doesn't matter what it is, it just gives you another chance to be able to talk about things that you disagree with, and have a dialogue and be willing to argue. I think that in a lot of ways we've kind of stepped away from really digging in and saying, I disagree with you and I'd love to talk about that, and not have feelings hurt. But I think those are kind of the areas that I look for.
Yeah, I think Charlie nailed it. And basically, everybody wants a better world for their kids, regardless of which way you vote. And although we often think of politicians as our leaders, actually they're followers. They follow what their voters want.
Yeah.
So if you can make connections with people, not only on your side of the fence, but on the other side as well, the politicians will listen and follow.
Very well said. Thank you both so much. This was, again, such an engaging presentation. I thoroughly enjoyed it, and there were a lot of compliments today, so I know everyone watching enjoyed it too. I will call it there with the Q&A, and in the remaining minutes, I'm going to hand it back over to both of you gentlemen for any closing comments you'd like to make.
Should have brought the banjos.
I should have brought the banjos. Well, I just, first, thank you, Curt, for taking the time to talk with everyone here and with me and sharing your expertise. I definitely learned something today, and I appreciate that. And thanks to all of you for joining us. It was a fun conversation. And any other questions, feel free to send me an email. It's charlie@twolined.com if you want to get in touch. And I'll be able to pass along questions to Curt as well. So thanks for tuning in, and thanks for being here, Curt.
This was wonderful, and definitely check out Charlie's artwork. Check out his music. If you're in the Adirondacks, come to Saranac Lake. He runs an open mic and a hootenanny in town every Monday night. You can check that out. And if you know any young folks want to study the natural world, in the real world, Paul Smith's College is a great place to go to college.
Absolutely. Well, thanks for all you do, Curt, and thanks for tuning in, everybody.
Well, thanks again, guys, and definitely check out Charlie's Instagram if you're on Instagram. Beautiful photos and video, too. So thanks again to both of you and to everyone who tuned in. Join us tomorrow for our next Daily Dose of Nature. You can check out the week's lineup, including registration links and replay links, on our website at nathab.com/webinars. We did record today's presentation, and we'll have the replay available on our website soon. And with that, I will conclude the webinar. Goodbye, everybody.
Bye.